Do you want to learn how to use Proteus and Arduino together to make project simulations? Then watch this tutorial from start to the very end. In today's episode, we will be making 3 projects in Proteus so that you can fully understand Proteus. I am making 3 projects in Proteus because in each project you will learn something new about Proteus. So don't skip the video and watch this completely. As you can see in the preview video, in fast forward we will be covering all these things. And for all those boys and girls who want to learn circuit designing and Arduino programming, they don't need to purchase Arduino and other sensors. For now, you guys can only start with Proteus. You can make cool projects in Proteus. If you are a beginner and new to circuit designing and programming, then at this stage all you need is just the software like Proteus and Arduino IDE. You can easily download these softwares. The projects that we going to make are number 1 relay driver circuit making and controlling, number 2 laser security system, and number 3 the time controlled machine. So while the Proteus is open, click on the pick from libraries button and write Arduino Uno. So just we will need this one and a resistor. We will also need a relay. Click OK. Right click and rotate. So now these are the pins. These are the 2 coil pins, 1 and 2, and this is the common pin, and this is the normally close and normally open, and it's a 12 volt relay. Okay, now we will also need 2N222 transistors, so 2N222, which is an NPN transistor. Double click and add, and let's trigger it a little bit. And we also need a resistor. We will connect this to pin 13 of the Arduino. Connect this one. It's where here. Now we will need some power terminals, so click on the terminals mode button and select here power. Double click and write plus 12 volts. Now select ground. Okay, now let's also add a lamp, so click on the component mode, click on the button which is the pick from libraries and write lamp, animated light bulb, so add also this one. And let's keep this side. Ground and power plus 12 volts. Okay, now let's start the programming. Let's save this first. Chip tutorials, relay driver, and this is the simulation. Now let's open the Arduino Uno and write programming. So integer relay equal to 13 and void setup and void loop. So pin mode relay is output. Let's keep the relay off by default, so digital write relay low, and let's write a very basic program in which we will turn on and turn off the relay after each and every second. So digital relay high delay 1000 milliseconds, which is equal to 1 second. Digital write relay is low and delay 1000. And let's compile this. Now as you can see, we have a hex file, so copy this link, press Ctrl C on the keyboard, double click and paste this over here and click OK. Now let's play this. Now as you can see, so the circuit that we have designed is working just fine. This is 2N222 transistor. This is a relay 10K resistors. We have added 10K resistor because it's a BJT, a bipolar junction transistor, and it's a current control device, so that's why we're just adding this 10K for the current limiting. Now my friends, let's start working on the laser security system using Arduino and LM741 operational amplifier. We will be using the LM741 operational amplifier as the voltage comparator. So let's get started. Okay, open Proteus and click on Pick from Libraries button and write LM741, which is an operational amplifier, as you can see in the description. Double click to add. Now we will also need an LDR, which is the light dependent resistor, as we are building a security system, so we will need LDR. Double click to add, and we will be needing some resistors, so write resistor and double click. So that's it for now. Click OK. Okay, now click on the LM741, add it, zoom a little bit, and we need an LDR, so and a power terminal plus 12 volt. And let's check the maximum voltage that we can give to LM741. So that is for the LM741 IC, that is 18 volt. Okay, so that is the power and plus 12 volt. Okay, we also need ground, and that is pin number 4. As you can see from the schematic symbol, the pin number 4 is the ground and this is the supply voltage. Okay, now we will need a resistor, and let's connect this with the ground. So now the LDR is connected in series with this resistor, with a 10K resistor, which makes a voltage divider. Now we will see how it works, but first of all let's add a DC voltmeter and see how the voltage changes when the light is changed. So click on play, and now as I'm increasing the light, you can see the voltage is also increasing. Why? Because the LDR is the resistance actually varies with the amount of light falling on the LDR. So when the maximum light falling on the LDR, the resistance is almost equal to 100 ohms. So that's why all the voltages drop across the 10K. So as I keep on increasing the light, the voltage is dropped over here. And when there is no light falling on the LDR, so it offers about like 10K resistance. So the voltage increases or decreases with respect to the light falling on the LDR. Now we will need the reference voltage that will be continuously compared with the voltage coming from this voltage divider, which will help us in detecting the laser light whether it is falling on the LDR or not. So click on the component mode. So we will also need a variable resistor for setting the reference voltage. So variable, okay, and now this reference voltage can be changed by rotating the variable resistor knob. And we also need terminals, that is the power and plus 12 volts and a ground. Okay, let's add another resistor. Just check the voltage at the output, and we need a DC voltmeter, and let's add it over here, this one, and let's add another one over here with the reference voltage and connect this with the ground. And now let's see how it works. Now click on the play. Now the output will be high when the non-inverting side is greater than the inverting side. It means when the voltage on pin number 3 is greater than the voltage on pin number 2. So as you can see, the voltage on pin number 2 is currently 6 volts and the voltage on pin number 3 is 3 volt. So the pin number 3 is less than pin number 2. It means like the voltage on pin number 3 is less than the voltage on pin number 2, so that's why the output is low, which is 0.96. Okay, now as the voltage is increasing but still it's less than 6 volts, it's 4, and still the output is low, 5, and now as you can see it's now 6.09, which is greater than 6 volts, and now the output is 10.9. So it means that the output is high. As you can see, now it's low because the 5 is less than 6, and now it's high. So if I change the reference voltage, now you can see now it's so it means using the reference voltage will help us also in adjusting the light intensity. So this is a very nice circuit. Okay, now as our aim is to signal the microcontroller, but if you look at the output of the IC, which is greater than 5 volts, and we cannot connect a wire from here with the microcontroller, so it means we have to add a transistor over here and then signal the microcontroller. So let's check 2x2 data sheets and see whether we can connect that or not. So open the 2N22 data sheets and let's check the base voltage. As you can see, the emitter base voltage is 5 volt and 6 volt, maximum 6 volts and 5 volts. So and in the simulation we can see that the output is 10, so it means we cannot connect connect a line from here to with the base. So it means we have to make a voltage divider over here. We have to add another resistor. So let's add and see. Delete this wire, add another resistor, and so now connect this with the ground and change its value. Let's keep it 1K, and now add a DC voltmeter. So we have to keep the voltage below 5 volts. Okay, when it's 10.9, it's 0.99, so which is more than enough for turning on the transistor. So that's fine. Okay, so now let's add a transistor 2N22 and a terminal ground. Okay, and let's add a relay which will also provide isolation, protection. Connect and a power. We can also add a resistor over here instead of the relay, and then we will give a 5 volt over here. But the relay is the best choice because it provides isolation and protection. If any short circuit occurs over here, it will not affect the microcontroller, or if the microcontroller is damaged, it will not damage this one because there is no electrical connection. It works on the magnetic field, so this will be safe. Okay, now let's see if it works. So now, as you can see, the relay can be controlled. Great. Now, how to connect this with the microcontroller? Let's add the Arduino Uno. Ground. And let's connect this with, let's suppose, pin number 4. And also let's add a virtual terminal. The RxD is connected with TXD and the RxD with a TXD. Let's save this. Okay, now that our design is completed, now let's start the programming. Open the Arduino IDE. Okay, now let's define pin integer laser is equal to 4, which is connected with pin number 4, and white setup and white loop. Let's activate the serial communication. Serial dot begin 9600, pin mode laser as input, digital write laser as high. We need a condition, so if digital read laser is equal to low, let's write activated. You can write anything over here, or maybe you can write intruder. Copy, paste, and if it's high, and write no intruder. And digital write laser as high. Let's compile. So we have this hex file. So if you can't see the hex file, simply go to the file, click on the preferences and check these two boxes, and then when you compile you will get this link. Just copy this, open, and paste over here in the program file. Paste. Okay, now let's play. Click. As you can see, there is no intruder. And now let's zoom a little bit. So now there is intruder. The relay has changed its state. Let's make a time controlled machine. This is the most important part of the video tutorial, because in this part you will learn how to interface an LCD, which is 16:2 LCD, with the Arduino Uno, and how to use push buttons with the Arduino, and how to do the programming. Pick from libraries. Right, first we will need Arduino Uno, so add this one. We'll be needing a resistor, and LCD 16:2 added. We will also need a variable resistor, so this one. Relay. Okay, now Here's a relay resistor, 10 kilo ohm, and relay. You will also need 2 transistor. As it's a 12 volt relay, so we need 12 volt. And of course down terminal. Okay, now we'll need the LCD. So the RS pin is connected with pin number 7, with pin number 6, so this is the RX, RS, and connected with pin number 6, and EN is connected with pin number 7, and D4 is connected with pin number 8, pin number 10, and pin number 11 is connected with 7. We need a push button. One and 2. Now, this button will be used for the start and stop operation, and this button will be used to reset. Let's write that. Click and write. Now let's connect the variable resistor. Plus 5 volt. So that's it. This is a circuit. Now we will start the programming. Let's save this. New folder. Simulation. So we have a start, stop button, reset, and this variable resistor will be used for the reset time, for setting the time. And this is a relay to which the output load will be connected, and this LCD will print the preset time and the time elapsed and the load status. So that's all. Now let's start the program.
So let's start the program. hash include liquid crystal.h. Hash define rs, that is 6, and we don't need any semicolon. And the hash define is used for the non-changing variables, so it's like a constant. Hash define en pin number 7. Hash define d4 8. Hash define d5 pin number 9, and hash define d6 10, and hash define d7 11. And the RW is connected with ground. Now liquid crystal LCD RS EN D4 D5 D6 and D7. Now we will define some variables for the time. So unsigned long previous ls is equal to 0, and unsigned long integer previous seconds is equal to 0. Unsigned long integer 6 is equal to 0. Unsigned long current is equal to 0. Now the variable resistor is connected to analog pin A1 of the Arduino, so integer time data is equal to A1, and integer time raw data is equal to 0. It's a variable. Integer seconds is equal to 0, and integer p minutes, which are pre-minutes, is equal to, that's the preset time in minutes. So it will store the value which is coming from the variable resistor. And integer minutes is equal to 0. Now let's define the interval. Integer interval is equal to 1. So it checks every 1 second. And integer start button, which is connected to pin number 2. So this is the start button. And integer load is equal to 13. So the output load will be connected with pin number 3. Integer R button is equal to 3. It's a reset button. Now we will define some flags. Integer L flag is equal to 0, so by default its value is 0 and it's actually a load flag. Now integer S flag is equal to 0, flag to monitor the start and stop, and integer C stop is equal to 0. It's to monitor the complete stop. Now wide setup. So LCD dot begin 16 2. So the type of LCD we are using is 16 into 2. 16 means 16 columns and 2 means 2 rows. So clear the LCD dot clear, and LCD dot print PT TELS. PT is for the preset time, and TE for the time elapsed, and LS for the load status. Now pin mode start B as input, and digital write start B high, so keep it at high level by default. Pin mode time data as input, again pin mode load is output, digital write load low. By default we will keep the load off in off state. So now pin mode R button is input. This button will be used for resetting, and digital write R button is high. So by default we will keep this at high level, as we will be using ground for this decision, and delay 1000. So this the delay I'm using over here, it won't affect the flow of the program, because it will be executed only one time when the controller is started. So now we will start the wide loop. Okay, now time raw data is equal to analog read time data. Now as we will be entering minutes in range from 0 to 60, so let's map that value. So the P minutes, which is the preset minutes, is equal to map and time raw data 0 1024, and 0 60. If digital read start button is equal to low, means if the button is pressed and is flag is equal to 0, then what to do? Then digital write load is high and else flag is equal to 1. If digital read start button is equal to high, if the button is released and is flag is equal to 1, what to do? Digital write load low, turn off the load and again change state of the flag, so flag is equal to 0. Now if digital read R button, which is the reset button, is equal to low, check if this instruction means check if the reset button is pressed. So what we're doing, make seconds equal to 0, also minutes equal to 0, and C stop flag also equal to 0 and close. Now if digital read start button is equal to low, if the start button is pressed, means if it is in closed form, so what to do? Current millis equal to millis, so it will store the milliseconds, and we know that 1000 milliseconds is equal to 1 second, so the current seconds will be equal to current millis divided by 1000, so it will give us 1 second. So if unsigned long current seconds minus previous seconds greater than or equal interval, and the interval will be defined as 1, then seconds is equal to seconds plus 1. Now LCD dot clear and LCD dot print PT DELS so LCD dot set cursor 01, LCD dot print preset minutes. So this instruction actually display the preset time, and now now to display the elapsed time, LCD dot set cursor 5 1. It means this is the fifth column on second row. LCD dot print minutes. You put dot LCD set cursor seventh column and second row. So LCD dot print dot and LCD dot set cursor eighth column and second row, and LCD dot print seconds. So it will display the elapsed time in minutes and seconds. Now we'll need some conditions. If digital read load is equal to low, LCD dot set cursor 12 1, which 12th column, and LCD dot print L. Now if digital read load is equal to high, then LCD dot set cursor 12 1, LCD dot print high. Now we will check seconds. So if seconds greater than 59, seconds equal to 0, minutes equal to minutes plus 1. If minutes greater than 59, then minutes equal to 0 and close a bracket, and previous seconds is equal to current seconds. Now if minutes greater than or equal to the preset minutes and load flag is equal to 1, then digital write load as low, make L flag is equal to 0, and also the C stop is equal to 1. And we will need another condition while C stop is equal to 1. What to do? LCD dot set cursor 12 and 1. So once this line of code is executed, then it will remain over here, and LCD dot print. So this is once the time is completed, so it will turn off the load and it will write L on the LCD. And if digital read R button. Well, if you press the reset button, it will start again. So C stop is equal to 0. Again I change the flag, and seconds is equal to 0, and minutes also equal to 0. And let's close this one, and another bracket, and another, and if minutes less than preset minutes and L flag equal to 0, and digital read start button equal to low, then digital write load as high, L flag make it 1, LCD dot set cursor 12 1, and LCD dot print high, and close it. So, so let's compile. Copy the hex file, press Ctrl C on the keyboard, double click and paste. Okay, so let's play. As the button is already, and it's okay. Now let's start again. Now as you can see, the button is open, so it's not doing anything, and also the relay is off. So when I press the button, you can see the load is high, the relay has changed its state, and the timer is activated, and now the preset time is 1 minute. This is 1 minute. I can increase the preset time from here by pressing this, so it's now 4 5. So let's keep it 1. Okay, and we'll see what happens. So meanwhile, if I press the reset button, it will start from 0 again. As you can see, the relay is on. So now you can see that the time is completed, 60 seconds is equal to 1 minute. So the relay is off now, and the timer has stopped. So what I will do now, I will just press the reset button, and you can see that it started again. So if I press this one, if I press the stop, and you can see now it stopped, the output load is off, the timer has stopped. And if I press the reset button, so if I press it again, it will start from 0. You can see. and if I stop it and start again, so again it starts from exactly from there. You can see now it stopped, and now again from here. But now during the runtime, while we can make it again start from 0 by pressing the reset button. So if I press again, it will start from 0. So the timer has started. You can see it came from. So this is how we can make a time controlled machine. It can be used anywhere. So if you like my video, subscribe to my channel, share my video with your friends, and thanks for watching.